This video is about polygons on the coordinate plane, and this is part 1. So for this video, our goals are to name the ordered pair of a point that is reflected over an axis, and also name the axis at which a point was reflected, given just the coordinates. Before we get started, let's review how to name ordered pairs on a coordinate plane. So you can see here that the horizontal axis is x, vertical is y. And when naming coordinates, you always name the x location first, then the y location. X is either right or left. Right is positive, left is negative. X is either up, positive, or down, negative. So we're going to name these A, B, M, R, P, J, and I would encourage you to pause the video and name them first, and then you can check your work. So A is located right 5, up, midway between 6 and 7. Those are both positive, right and up. So it's positive 5 and positive, I'm going to say 6.5, 6.5. B is left 6, up to 7. So left is negative, negative 6. Up is positive 7. M is located left 4 and then does not go up or down. Therefore, it is negative 4, 0. R is left 8, down 5. Negative 8, negative 5. P is neither left nor right, which is 0 for your x, but then down 5, so negative 5. And J is right 7, positive 7, down 5, so 7, negative 5. So when it comes to the coordinate plane, remember that, scoot this over just a little bit. When a horizontal number line and a vertical number line intersect, they form the coordinate plane, as we just discussed. The horizontal number line is called the x-axis. The vertical number line is called the y-axis. The x-axis and y-axis meet at 0. That's called the origin, and all of that is labeled here. A reflection is a mirror image of a shape. So think about when you look into the mirror, that is your reflection, okay? You can reflect a point in the x-axis, in the y-axis, or in both. You can see that the red points are mirror images of each other, and you can see that they are reflected across the x-axis. The line between is called your reflective line, okay? It's your point of reflection or line of reflection. And because they are jumping over the x-axis, their x values are the same because they're both right 1, but their y values are opposite. This red is above the x-axis by 3, and this is below. So 1, 3, 1, negative 3, okay? The blue points are mirror images of each other, but they're reflected across the y-axis. One is to the left of y, and one is to the right of y. This time, because they're over the y-axis, their y values are the same, but their x values are the opposite, okay? So let's take a closer look. These are reflections on the across the y-axis. Okay, so our line of reflection is the y-axis. Point A is located at 2, 3, and its reflection is located at negative 2, 3. Okay, as a result, the x-coordinates of point A and its reflection have opposite signs. One is positive 2, one's negative 2. So what you need to remember is whatever it's reflected across, that's what stays the same. So when it's reflected, this is something that you should write into your notes. When this is reflected across the y-axis, your y stays the same, but your x changes to the opposite. Now, if it was already negative, then it's going to change to a positive. But again, your y stays the same. If it was negative, it's going to stay negative. And I should add that in right here. Okay. Same goes for reflecting across the x-axis. X stays the same. Y changes to the opposite. And you could write that same thing in here. So go ahead and try practice problem 1. Each point's been reflected either over the x-axis or y-axis. Can you select correctly which one? So go through and look to see what stays the same, what changes. So in this example, I can see that my x value stays the same. Therefore, it's reflecting across the x-axis. For the second, B, I can see that my y value stays the same. Therefore, it goes across the y-axis. And C, I can see that my y stays the same. Therefore, it goes across the y-axis. If you wanted to double check, you could sketch a little coordinate plane, but remembering these rules will help you be successful with this. Practice problem number 2, a point at 3150 is reflected over the x-axis. This is an example of one where you definitely want to know the rules because you don't want to have to spend time graphing this. What are the coordinates of its reflected point? It's going over the x-axis. Therefore, the x remains the same. This will stay as positive 30. The y value goes to the opposite, negative 150. And it's that easy. So before you leave, make sure you can name ordered pairs of a point that's reflected over either the y or the x-axis, and also name the axis that a point was reflected given the coordinates. Thanks for watching.